welcome to our Talking Timber webinar focusing on timber and acoustics. My name is Samantha Charles, and this webinar is brought to you by Sawmilling South Africa, Stellenbosch University, the University of Pretoria, and the York Timbers Chair in Wood Structural Engineering, as well as our title sponsor, Rothoblaas South Africa. Rothoblaas is a global company from the Italian Alps and a leading creator of high technology solutions for the heavy and mass timber, energy efficient, net zero, and other better building practice sectors. It has a range of products, including fasteners, connectors, building envelope and acoustic solutions, worker safety, and tools. Rothoblaas opened its South African subsidiary in 2018 and have recently invested in warehousing property in Cape Town with a long-term goal of working hand in hand with the relevant role players in the market to explore and develop potential for timber and mass timber construction in Africa. And as you will know, South Africa is rich in opportunities for the development of mass timber, especially homegrown and locally processed timber by our sawmilling industry. And today, many designers are involved in the construction of timber process structures, such as terraces and patios in resorts and hotels. And local sawmills, represented by Sawmilling South Africa, are becoming more structured, and solid timber construction is also gaining ground every day, thanks to Rothoblaas's products. I'd also like to acknowledge the Department of Trade, Industry and Competition, represented today by Mr. July Mokwena, the Deputy Director of Forestry-Based Industries at the DTIC. The South African Institute of Architects, you'll be pleased to know, has assessed and validated this webinar as a Category 1 CPD activity, and today's webinar will carry 0.15 CPD points. We will be submitting today's attendance to the Institute, and you will be eligible for CPD points if you attend the full session. We are able to track if you log on and off for 5 minutes. You would have supplied us with your details, and we will submit these to the Institute. In terms of communicating with us and making this interactive, there is a chat functionality as well as a Q&A. You should be able to see the Q&A. So please use that to address any questions to our speakers as the afternoon progresses. The session will be recorded. You would have got a pop-up message to say it's been recorded, and previous webinars are available on the Sawmilling South Africa YouTube channel. And we will also have some polls towards the end of the webinar. So I just want to take you through some of the events for the timber-related industries coming up. So there is a design for manufacturing and assembly, a digital webinar or virtual webinar next week. So you can go and vote and then relax with a glass of wine or cup of coffee in the evening from 6 to 8 p.m. For the this interesting webinar. There is the registration address, but I will post this document in the chats for you to access. There is WoodX for Africa coming up soon at Gallagher Convention Centre from 4 to 6 June. And yeah, it's always an interesting exhibition. It's also got some co-hosted exhibitions like the Big Five and construction-related exhibitions. And then WoodApp, one of our flagship initiatives through the Stellenbosch University, Philip Crafford, who is one of our speakers today, is hosting a workshop alongside Jamie Smiley and Michael Kloos, and that's on the 5th of June. It is in Stellenbosch. And so you can reach out to Philip to book, or you can actually click on the link to book. And again, I'll provide these links during the course of this webinar. And then we have an annual general meeting for Sawmilling South Africa on the 12th of June at Future Africa at the University of Pretoria. And we have an open session where we will have various speakers, and we will send out a communique to you. So if you'd like to join, if you're in the area, you're most welcome to come along. And then in September later this year, you can There's the Timber Construction Conference hosted by the University of Pretoria and Skull Grobelaar. He's posting some links for you now in the chat. Again, that's another interesting conference that you can attend. And then there is also the timber design competition that is open to students in the architecture and similar bodies and the construction related sector. Here are just some of the details. So again, we will post the links to these competitions and initiatives later in the program. So I just want to introduce our speakers to you today. So we have Dr. Philip Crafford. He's currently working as a postdoctorate fellow at Stellenbosch University alongside Professor Brunt Wessels in developing online timber building courses, CLT prototypes and CNC projects. He has also published numerous papers on timber in South Africa and was core to the development of the Wood App initiative by Sawmilling South Africa and Stellenbosch University. We also have a case study by Niel Crafford, who is an architect with extensive experience, having worked widely in Southern Africa, East Africa, Egypt, the Middle East, and the Indian Ocean Islands. I've said to him that we need to have a site visit to some of these exotic locations. It would take apparently 2 days to get there, so we'll have to see about that. He also has experience in most conservation and ecologically sensitive areas in South Africa: Namibia, Botswana, Zimbabwe, Swaziland, Lesotho, and Mozambique. And Niel is currently a director at PlanEco and a partner at Crafford & Crafford Architects that was founded 25 years ago. And lastly, on our speaker list is Mark O'Connor, the aerial sales manager for Rothoblaas, South Africa. He has been with the company since 2017 before setting up the subsidiary in 2018. His background is in sales in conventional construction before he discovered Rothoblaas, and has since then been enjoying sawdust in his socks. And then later on, we will have July Mokoena delivering some closing remarks. So without further ado, I'm going to ask Dr. Philip Crafford to, give us his presentation on timber and acoustics. Over to you, Philip.
So today we will look at the fundamentals of sound and the principles of sound control, how to manage sound behavior, especially in timber buildings. We will look at the two relevant SAS building codes when it comes to residential and non-residential buildings and acoustics. And then we will look at a few timber details, mostly timber frame and some CLT design details for acoustics. So wood can either enhance sound or absorb and manage sound. We know right across the world we use wood for many instruments, and at the same time a lot of times the recording studios are manufactured from wood elements, and so it has the ability to either enhance sound or control sound depending on what you want to achieve. Looking at the fundamentals of sound waves propagate in all directions, so it's good to understand how sound waves move from the source. And also sound waves differ in terms of loudness and pitch. You will get either higher or lower amplitudes, and also different frequencies in which sound travels. Considering the table on the left, the speed of sound differs for different mediums. If we look at air is a lot of times considered as a constant, and the travel speed is only 350 meters per second at 0 degrees Celsius. And then different mediums like brick and wood and concrete has higher sound speeds as the sound wave hits those mediums. And it's interesting to note that there's a difference between softwood and hardwood. Softwood, the sound speed or the speed of the sound medium or sound wave would be closer to 3,000 meters per second for softwood. For a denser hardwood, it's closer to 4,000. Then you can go all the way up to steel or aluminium, where it's more than 6,000 meters per second. On the right-hand side, we can look at the table in terms of decibels. That's the loudness, how we typically measure sound. And whisper would be 50 decibels, for example, in a face-to-face conversation, almost similar to what we're having now, would be 60 decibels. And then all the way up to very loud noises like a jet engine of more than 100 decibels, 140 decibels actually. So our sound behaves looking at some principles of sound control, or at least the behavior. Sound can either be reflected or absorbed, diffracted or transmitted. And if you look at the picture on the right-hand side, if you build a simple internal timber frame or a drywall construction, one would say, you would see that that would happen if there's no insulation or the right design. Sound would be either reflected, absorbed, or transmitted without getting a very good decibel grading and acoustic performance. So then you might still hear someone if they shout or speak loudly, you can still hear someone in the next room. So we will look at some details to overcome that issue. Also managing sound inside of rooms. On the left, you see a perforated sound absorption panel that's used for reverberation control or echoing and managing, I would say, white noise in auditoriums and classrooms to equalize and stabilize the movement of sound and noise. And at the same time, on the right-hand side, you will see mineral wool insulation in ceilings. So by adding this, and even a suspended ceiling, you already improve your acoustics by a high degree. And we will look at more detail just now. So this type of ceiling will also manage incoming sound from outside. Considering the two of the relevant building codes that deals with acoustics and buildings, residential and non-residential buildings, SANS 10103 deals with the measuring and classifying of areas into either E1 or E2 zones that is classified, say, for residential development and for perhaps industrial or other uses. And then SANS 10218 Part 1 especially deals with the grading requirements for different buildings on the facades or the inside between rooms, different bedrooms or bathroom, all have different gradings. And then also, if you look at the tables on the bottom side, table 2 and table 4, they will have an HG and an SG, which stands for high grade and standard grade ratings that one can consider as an architect to obtain your required decibel or performance. And then what's interesting to note is at the bottom on the left, it says it is not advisable to erect residential buildings where the outdoor ambient noise rating level exceeds 55 decibels. So even if you design the best building, if you use a glass or normal doors and a standard roof, you will have trouble by managing the indoor noise environment if your outdoor ambient temperature too high. And on the right, it says noise within a dwelling unit is more readily controllable than elsewhere than the sound insulation requirements. Therefore, it depends on the lifestyle of the occupant. So what it's saying is inside noise is a different approach than outside noise, because it's possible to control your inside environment. If you have a team, they like playing loud music, or that's something you can control. Or if you know where to place your bedroom in your house, you can take it away, perhaps not next to the bathroom or the kitchen, etc. So I will now move to the next part, or perhaps just saying something on part 2. SANS 10218 Part 2 deals with the procedures to grade buildings, so existing buildings and new buildings, how one would perhaps submit your plans to council in terms of the right acoustic ratings. Again, on the left, one would see an example of timber being used to manage sound, to absorb sound, and to equalize sound in a building environment. Perhaps it's also interesting to note that furniture, curtains, carpets, all of it plays a big role in acoustic performance of a room. And on the right-hand side in this auditorium, you would see that these panels are used to equalize or to equally distribute sound movement in that room. Considering some timber details, on the left-hand side, this is a typical section detail of a timber frame house where two rooms or two houses come together, perhaps in a duplex setup. And on the left-hand side, you will see they use double lining internal walls. And of course, in the cavity, you can add your insulation, and the walls are not connected. There must be a small space, and then you get a very good acoustical performance. On the right-hand side, you will see this illustration from the SAS. Even for an internal wall, you can do a staggered stud design. And I know some of the contractors or timber frame builders in South Africa, they use this design a lot, and they achieve very good performance. And of course, you can install your rock wool or mineral wool and in the cavity to build your own little sound room, if you like. Looking at this on the left-hand side, the section detail of a floor assembly. This is a normal suspended timber floor. And then this is where resilient sound insulation clips and the furring channels become very, very important and interesting if you want to achieve a very good acoustic performance in your floor and ceiling assemblies. So at the bottom, you can do that. You can, in the cavity of the joist, you can include your mineral insulation or other type of insulation that you specify, depending on the R value. And of course, so what you want to achieve as an architect. And then at the top, there's a subfloor, and then there's the battens on the resilient pads or the cradles. So you can see the top floor is actually isolated from your joist, so it prevents vibration. And then there's some more insulation and your final floor. So you can really build up a Rolls-Royce floor where you can get very good performance in terms of acoustics if you do it in the right way. It's important to specify the right resilient channels or furring channels and using the right insulation clips for the job. The same is true for CLT. If you want to use CLT floor slab, you can add your resilient sound insulation clips and furring channels. You can add, if there's a cavity, you add your cavity bat or your insulation of choice. And on top, you can do the same with isolating the floor by introducing these resilient pads and cradles on battens running perpendicular to your floor. The same, some people specify a sand and sawdust mixed on top of the subfloor, on top of your joist. They would introduce a denser material. Some people would go for lightweight concrete or cement. All of it can get very good results depending on what you want to achieve and your design. Finally, we consider wall assemblies and flanking paths. So it's important if you have a duplex or a multi-story apartment where they're built like this in many countries, it's important to isolate the floor paths. Otherwise, the acoustic or the frequency and the vibration might travel from the one house to the next. And I've been in steel constructions where I could hear someone coming up the staircase in a steel building that is 20 rooms away from the one room or 10 rooms. So if everything is connected, you can feel the vibration in a light construction. So this short webinar or presentation was based on this online short course. So you are welcome to check it out for more detail. The Wood App Sound Control and Timber Buildings. And I hope you book for the CLT workshop. We are excited. We still have about 20 seats left on 5 June. Thank you very much.
Thank you so much. If you could just unshare your screen, and then I'll hand over to Niel, and he can share his case study on a project that he did in Mozambique.
Good afternoon, everybody. It's an honor to see so many people attending this course. I noticed from the chat box earlier on that the people that registered where they're from, quite a lot of you seem to be from the coast, and I find that very interesting. I'm sure we can have a discussion about it afterwards. Not many people, inland people in South Africa, actually do timber frame construction. So maybe it's all happening down at the coast. Okay, let me just share my screen here. Okay, the project I want to talk to you about is at Ponta Membane in the Maputo National Park in Mozambique. That first slide shows you a drone shot of the actual development hidden amongst the bushes and nobody on the beach. Right, so let's get this on. Samantha, you gave a very good background sketch about our practice. Thank you very much for that. We have been very blessed to be able to work quite widely in most of the ecotourism industry in Southern Africa and a little bit further afield. And quite often we had to come up with alternative construction methods because of the remoteness of the site, or maybe just because we would like to add some excitement to the destination and rather not have a brick and mortar building. So we have experimented with a lot of other construction methods over the years. Just to indicate where the Maputo National Park is, for you, those of you who haven't been to Mozambique recently, there's a road map indicating in blue from Pretoria the road you would take. The N4 takes you through Komati Poort, Rosana Garcia, and down to Maputo. You cross the new bridge at Katembe. Up till 3-4 years ago, you had to take a ferry if you wanted to follow this route. Now it's a tarred road all the way down to the Cozy Border Post on the south and down to Ponta de Ouro. And the Maputo National Park is that green area to the south of Maputo Bay. It's about 100,000 hectares. I'll give you a bit more information about that just now. Conservation area of the Maputo National Park. It used to be called the Maputo Elephant Reserve for many, many years. And then about 15 years ago, they changed the name to the Maputo Special Reserve. And only in 2021 was it proclaimed a national park, which also includes the Ponta de Ouro Partial Marine Reserve. That joins up with the Isimankalisu Wetland Park, the Marine Reserve as well. So it's a huge conservation area. You'll notice at the bottom part of the park itself, there's a finger that goes all the way down to the South African border. It's called the Futi Corridor. The Futi River has been fenced on both sides, and it's the intention is that once it's opened, which will be sometime soon, then the elephant populations of the Maputo National Park and the Tembe Elephant Park in South Africa will be able to get together again. They were separated many years ago. Our client, we had a dual client, Peace Parks Foundation, which is a South African organization that was started in 1997. And they've been very active all over the southern part of Africa with what they call trans-frontier conservation areas. First one was the Kalahari and Trans-Frontier Conservation Area, which included the Kalahari Gemtok Park in South Africa and the other one in Botswana as well. The Greater Limpopo Trans-Frontier Conservation Area is also quite known. That includes Kruger, Parque Nacional de Limpopo in Mozambique, Banini and Zenav National Parks, also in Mozambique, and also the Gonerezu National Park in Zimbabwe. The buildings were handed over to ANAC, which is the conservation authority in Mozambique, and they have 7 national parks all over the country that they're looking after. The national parks had a hard time during the Civil War, but lots of them are now getting back on track with private involvement as well, like the Peace Parks Foundation. They involved in, as I said, the Greater Limpopo National Transfrontier Conservation Area, in the Maputo National Park. And then we have people like Greg Carr, who's been involved with the Gorongosa National Park for quite a number of years as well. The client's brief, I'll put on a few items here, but I'll be brief. I'll just talk about two, was to develop these touring facilities, and most important that the facilities had to be low impact and environmentally friendly. And it must blend in with the natural environment, and that the impacts during construction must be limited with off-site pre-construction as far as possible. Those two items really led us to the building system, the structural timber frame, the timber panels, cladding, etc., which was able to be transported to site. Just by the way, I didn't mention it, but the entrance into the park is at Puti Gate, and from there it's deep sand for 45 kilometers to Ponta Memban. So you need to have a proper 4x4 to get there. And also transport of building material obviously had to go the same way. Design influences, mostly to not spoil the environment, as I pointed out earlier on. We try to ensure this by making sure the construction methodology is suited to the conditions on site. The deep sand are referred to, lightweight construction elements that are small enough to get through the narrow winding tracks on the way to the site. The buildings were positioned very carefully to minimize the cutting of trees and branches, and all cutting, clearing, trimming was done under my supervision. I had a little team with a chainsaw and a few katanas or machetes if you want. And that's the only time that the chainsaw worked, was when I was on site. Otherwise, it was hidden in a stall. People can get quite dangerous in the bush if you're not looking after them. The building material had to be controlled. Material was carried onto site by hand. No little dumping trucks all over the place. All footpaths were properly demarcated, and that's the only place that people are allowed to walk. And then waste was very carefully monitored. It was separated on site and then taken to the gate and handed to recyclers or properly dispensed off. And then most importantly, the time on site was limited by designing a system that was manufactured to a large extent off-site and then just assembled on site, almost like a Meccano set. The other factors that influenced the design was the height of the tree canopy. So the roofs were broken into smaller segments and kept at a 15-degree angle so that they don't stick out above the trees. That first slide might have shown you that. The slope of the terrain, it is on the coastal dune part of the development. So very little leveling was done. The units were actually lifted off the ground, as you'll see just now. And it's very close to the ocean, so no normal metal, just stainless steel and aluminium were used right throughout. Roof sheets, bolts, nuts, door handles, everything had to be rust-proof. Prevailing wind was kept in mind, and it was also used to assist with the ventilation of the units. And then lastly, the colors were chosen to blend in with the natural surroundings. Just briefly, not so much about the construction, but we wrote an architectural language document which looked at the factors that should be taken into account when designing these buildings. The little sketch in the middle on the left-hand side shows what the landscape looks like from the top, if you were to go to Google Earth. On the right-hand side of it, you'll see the Indian Ocean with a ponta, that has to be Ponta Memban. The pontas, just by the way, are these outcrops or bays and points that you find along the Mozambique coast. The most southern one being Ponta de Oro, just above it Ponta Malangane, then you have Ponta Mamoli, and so on and so on. Quite a few of them inside the national park as well. You then have huge grasslands with beautiful inland lakes next to it, reeds around it, lakes full of crocodiles and hippos, obviously, and incredible bird life. You have the vegetated dunes on the way down to the beach as well. You have swamp forests, you have coastal forests. It's one of the most pristine conservation areas, I think, in the whole of Southern Africa, that I've been to anyway. And mostly so because before the road was tarred between Maputo and Ponta de Oro, or Cozy Bay border post, it was not an easy road to take. It was sand tracks all over the place. It would take you, on average, if you were to drive from Swaziland to Goba border post in Swaziland down to the site, would have taken you about 6 hours. That's in the dry season. In the wet season, you might find deep water puddles that might delay you even more. Nowadays, it's an hour-and-a-half drive. So the good thing about that was that it wasn't impacted so much by humans for many, many years. And that's why it's such a wonderful environment to be in. Let's look at the concept design. Oh, sorry, maybe if I... No, that's okay. If you look at the design itself, that is of a typical bedroom unit. There are 6 different plans for different conditions on site, also for families or for couples. And also some of them you entered from the back and others you entered from the front, just because of the way they sited in the bush. So we ended up having 6 different plan forms. The construction methodologies are fairly simple, but what we try to achieve, and you see it on the next slide as well, is to have a building that sits lightly, that is open to the environment in which it is, so that you're aware of that environment, and that obviously doesn't need air cons and things like that. That is a habitable space to have. A little section there will show you that is almost like a see-through building with big sliding panels in the bedrooms and other places that you open up, so you invite outside in. The dining room or living space is completely open, just got a wall on one side and a front door with a key. Not quite sure why I put the key in, but anyway, you can get onto the patio from the bush on the other side if you wanted to. You can see the 15-degree sloped roof panels in smaller segments with lots of box cutters in between. We did end up having a leak-free roof, but it took some time to get there. Not because of the box cutters, but because of other factors that crept in. On the bottom right-hand part, there's an exploded view of the construction, but I think it'll be easier to explain it to you with a little sequence of sketches I made in the beginning to explain to the client how we're going to build this. You start off having your gum poles, which we planted in sand, just dug a hole, put them in using laser-guided technology so that they're all in the right place, obviously. And then filled it back with sand with a 10% mix of cement. It's called swellcrete, and we just dampen it and you stamp it down. No concrete foundations at all. On top of which you put the bearer beams to do 8 by 50 mils, all treated, obviously. You then put the joists at 450 distances because of the decking or the marine ply floors that goes on top of it. Interesting, normally you'd fix those joists with hurricane clips, I think they're called, but galvanized members that you could screw to both the bearer and the joist to keep it in position. There were no stainless steel ones on the market, so we couldn't do that. We ended up putting in 38 by 38 little pieces of wood that you can screw to both bearer and joist. I'll show you on the photographs later on to replace that. The plywood boards or the treated pine decking then went in next. The laminated timber frames came, which were 132 by 132 laminated timber produced by White River Sawmills for us. And it was sent in long lengths to Ecolog Homes in Johannesburg, who then cut them to size and notched them where they needed to so that the columns and the beams can be fitted together. And they also made all the other SA pine, treated SA pine panels that goes in between the structural frames. Once those were up, and also obviously other beams in the other direction, the first top left-hand slide indicates the one directional columns joined with a ring beam on top. And then in the other direction, we had shorter ring beam pieces that were put in and kept in position with galvanized brackets and stainless steel screws. Right, so they were put in, the gutters were put in, the roofs were then put on top. The roofs are structural insulated panels provided by Isowall. It's 100 millimeter of polystyrene with aluminium sheeting top and bottom. They clip together on site in a supposedly watertight joint, which we later found out wasn't quite that watertight. So we had to have a top hat section made, which was pulverized on top and sealed, obviously. And those panels are wonderful because they can span 5 meters without having any additional support. And that made for a very clean and neat ceiling layout on the bottom. And then lastly, the cladding and the roof panels and the windows and the doors goes on. Just a side plan, north being towards the right, the Indian Ocean's at the bottom of this drawing. Then you have the primary dune on which in the middle you have 8 what they call dune chalets. We also have the restaurant there. We'll show you a slide of it later on in the pool area. In the forest to the left, or to the south rather, of the primary dune, there's a very thick forest area, but luckily quite level, in which you put 8 forest units, or we call them hilltop units. Hilltop units. And then towards the back, because of limited space along the primary dune, we put in a further 8 forest units, the reception area and the star village. I'll just quickly run through the technical drawings. There were many of them, I can assure you. If you do a brick and mortar building, then you draw 2 lines and you've got your wall in plan. If you do a alternative construction building, then you do like 9 or 10 plans before you've illustrated everything that goes into the construction of that wall. So it definitely was it's a very steep learning curve for us. We just kept on drawing forever and ever. Fortunately, it was during COVID, which kept us off-site for a year and enabled us to finish all the drawings in time to go to site. Typical section, elevations at the bottom, indication of the type of drawings you need. The one on top is just the bearers. Underneath it would be the placement of the gun poles itself. On top of the bearers, you have the joists, and then on top of that, just not on top of that, later on you have a roof structure. We had some shading elements along the sides. The gutters layout, and the gutters all had to be designed because on the sides of that box gutter, you would have either a flat roof or a roof at a 15-degree slope, or an upstand window, vertical window, or nothing at all. So lots of gutter profiles. That was nuts, I can assure you. Typical chalet drawings further on, the cladding layout. The internal cladding, external cladding quickly was fiber cement sheeting, normal fiber cement sheeting, fixed to a treated timber panel, and having a vapor barrier first, onto which you put the cladding, and then it was sealed on all sides. The internal cladding came in later, once all the services were put in position, and the internal cladding consisted of PVC foam board, which was a fairly new material at that time on the market. Wonderful stuff to work with. It doesn't crack. You can router it, you can drill it, you can do everything with it. And we ended up not even painting it. It's got a washable surface, and they're all white. And we fixed them with stainless steel screws imported from Germany. So they're very nice looking and they're very expensive. So we didn't even hide the screws. You can see every screw that we used to fix the panels with as you go into the building. Lots of details to indicate all the different materials get together and how you make it waterproof, etc., etc. Right, let's get to some of the photographs then. Top left is me in the bush before it was cleared finally. It was a very, very interesting experience setting out these buildings with elephants taking down the danger tape that we put up to mark roads and building positions. Every time we come back a month later, then we have to redo part of the job. You can see the gun poles in the middle photograph, the joists on top of the bearers. Bottom or middle left rather, you can see some of the services going in. You also notice that there's the vertical 38 by 38 piece of timber that keeps the joist in position on the bearers. I mentioned that earlier on. Some of the structural frames going up, clamped together. Each one of them was numbered and colored to know to which building it belongs and also where it must go into the building itself. It was during the rainy season, so we had to take protective measures against the wet conditions. Some of the treated panels going in. There's some more photographs of the actual construction process. Most of the wall panels in, the roof sheets in position, some of the services going in. The roof sheets were wonderful. So the ceiling, it was a pre-painted aluminium sheet, smooth one, and the top one was also pre-painted in a charcoal grey color with a slight, very slight profile on it. We didn't want to have a deep profile because then the leaves that fall down all the time might get stuck on the actual roof panel itself. Right, quick look at some of the completed shallows. These are the forest beds. We call them forest shallows rather. This is a 4-bed unit. It's got an external dry area. You can see the bigger photograph. You can see it's a fairly open building. The dining living space is in fact very open. And then the bedroom, if you look at the left-hand columns, the second one from the top, that's the windows. But then when you open these sliding panels, then you actually feel like you're in the middle of the forest. The dune chalets were long, narrow buildings because they're on the landward side of the primary dune. It's got quite a steep fall on it. So they're long, narrow little buildings. The big photograph indicates the bedroom with a whole wall panel that slides open, which is actually the door to the bedroom, but it slides open to have your living room actually become part of your bedroom as well. The columns of photographs on the left, the second one from the top is the bathroom. Once again, a whole wall panel that slides open, and then you have an outside shower if you want to. Hilltop chalets, some of the photographs taken at night. We used LED light strips very effectively, which were aligned to shine up against the underside of the roof panels. So you have a beautiful diffused light, no exposed lighting. Once again, we want to have a minimum impact on site. The restaurant building, we still collect rainwater from the roofs, and that gets treated with the whole treatment plant and then becomes a drinkable water. The development is provided with a borehole, but there's a lot of iron in the water, which makes it unsuitable for human consumption. The restaurant's the only building that looks out on the beach and that you can see from the beach. It was positioned in a place previously opened by a campus. Not supposed to have done it, but the bush was taken out on top of the primary dune, and the dune started eroding away, and the EIA allowed us the opportunity to say, we'll put a building there and then prevent further erosion in future, and they allowed us to do that. The reception building, there's one viewpoint at one of the smaller restaurants that overlooks the beach. And it's used mostly during the mornings and late at night. During the day, the wind quite often blows. So the lapa to the left, you can see there's a lapa with a fire, is a very protected area adjoining this deck, and that's where you would normally have your meals. There's a 300-meter long boardwalk that connects the dune chalet units. This is on the seaward side of the primary dune. Pardon me, it's got a wonderful view across the beach when you walk between that and the restaurant. And then just out of interest, the timber frame construction, and I'm sure a lot of you have seen this in the past, is done quite widely in Mozambique, and it seems to me like it might be the case along other parts of the coast in South Africa as well. And it's a timber frame thing that you made up with pre-made panels. You connect them together, you put up your trusses, you put conventional cladding inside and out, you have a sloping roof fall, most probably fiber cement roofing as well. So it's not rocket science. Not many architects do this, but that's the way most buildings get built in Europe and in America as well. A couple of side views just indicating that you don't really see the development except for the restaurant, as I pointed out. And just look at the time here. We achieved, I think, my two main objectives were the following. I would have loved to not have you see any buildings when you arrive on site, that you would park your car in a car park. There would be a sign saying this is a car park, so you park your car. And only when you walk through the first 10 meters of bush and you get to the reception do you know there are actually buildings in this development. And it turned out like that on site. Should you ever get there, you must probably experience it that way. And then secondly, you we wanted people to become part of the environment and to enjoy this incredible natural environment that the building was put up in. And I think we've managed to achieve that as well, with the openness of the buildings and the very simple architectural design. We actually allow nature to provide the focus for the development. We spoke about most of the sustainability issues. Yeah, we've got good cross ventilation. The highest point of the internal space, where the sloping roof is at the highest point, we've put in very finely perforated panels, so that all the hot air can escape under the roof sheets. There's cross ventilation through all the buildings. We've got fans in it. It gets very hot there in summer, and the humidity is very high, so a fan would help a lot. Yeah. And then we have our project team. We had an incredible, well-organized project manager, Louis van der Merwe, who lives in White River. Him and I used to go down to site together. None of the other professional team really got there on a monthly basis, put up a little tent, stay there for a few days, do our site visit. And we had the most incredible contractor, Felix Construction, nowadays called Radix. They're based in Maputo, in Matola. There's an African guy that heads it up. And in my 42 years in architecture, they have been the best construction team I've ever worked with. Incredible. We were so happy to have them on board. That's it. Thank you very much.
Thank you so much, Niel. Yeah, looks absolutely beautiful. You're getting a round of applause from all the delegates here. So yeah, it's stunning, and well done to your team on a very ecologically sound construction. So maybe you might even get a few people wanting to visit. So thank you so much. So next up is Mark O'Connor.
Thank you very much, Samantha. Very, very impressive structure that we've just seen. My only comment is that wish you guys had known about some of the expensive Italian screws around, but I digress. We talk about soundproofing solutions today. You know, we, as a guy that works for an Italian company, we have quite a big insight into what's happening in the European market. Fire and acoustics are two of the really big topics currently being investigated and tested in Europe. The other really big one at the moment is high capacity beam hangers or hidden connections. And all of that is all incorporated to take very, very high loads and also how they react in fire. In terms of what we do when it comes to soundproofing in timber structures, it's an area where Rothoblaas heavily invests in. And we are one of the industry leaders, if not the industry leaders, in product design, testing and certifications for acoustics in timber buildings. Yeah, we believe you are in good hands with our products. And I'd just like to bring you to the front page of our soundproofing solutions catalog. As you can see how the market has changed and evolved, and how your mass timber structures can include a variety of different materials, and of course how they interact with each other. Very common to find steel, which is quite a good material to. I think it complements mass timber very, very well, but it's not a very acoustically sensible material. And actually, timber can also be good or bad depending on how it is specified or how it is designed. So yeah, that's what we're really looking to overcome is how these materials interact with each other and how best we can detail the structures. Just a few notes on noise. We have 4 main types of noise, and there you will find that noise often one type of noise may sort of present itself as possibly more than one category. So you'll have impact noise. A good example is someone walking on a suspended timber floor. Airborne noise, which is what you're hearing right now. Structural noise, which Philip touched on, flanking essentially, and this is how noise will actually go and go around through the structure, notably in fixings, steel elements, and then of course acoustic and ceilings, which is basically the sealing of air gaps. One thing, when we talk about acoustics and soundproofing, we use decibels, and these are often not very impressive numbers when we talk about a performance of how much performance improvement you will get. So just to give you guys a brief understanding of how decibels work, it's a logarithmic quantity, so it can be said that 3 decibel increase is equivalent to doubling of sound energy. So essentially, if you have a radio plus 10 decibels, that is now equivalent to 10 radios. So when you understand that you're not looking about, you're looking at making small savings or small improvements in decibels. I hope that gives you a bit more clarity on the numbers that we're talking about. From in our experience, you have 3 main objectives when it comes to tackling sound. You typically want to look at sealing of any air gaps, and your first jumping off point would be the correct use of membranes, foams, tapes, expanding profiles. Second thing that you want to look at is adding density. As Philip was mentioning, sand and sawdust. I've seen, for example, on a Swiss building show where the guys had a CLT floor slab and they had upstand joists on it filled up with aggregate. And also, that would also, in terms of adding density, you can also use off-the-shelf construction materials. So, and then acoustics often fights a bit with engineering, because a good acoustic engineer would like to split up the elements, and a good structural engineer would like to tie everything together. So it's a little bit of a dance between the two, and how best you want to solve it, and also how far down the rabbit hole you want to go in terms of creating an acoustically comfortable building. In terms of design, when we looked at Niel Crafford's project, the one thing I noted on his 4-bed unit is that the bedrooms were on either end of the house, or of the unit, which makes a lot of sense. So you have your bedroom separated quite far away from each other, and your living room right in the middle. It also makes a lot of sense if you have a double-story house to possibly have your bedrooms upstairs and your living area downstairs, just from a design point of view. When it comes to soundproofing, it is better to plan ahead to make sure that you're not leaving anything to chance at the design phase. And retrofitting acoustic solutions is not always very effective. It's not always very easy. When we talk about acoustic walls and ceilings, I often find that these are sometimes specified a bit later or designed to include a bit later, but these are brilliant products for reverberation, so sound inside a room, but not always the best option for sound that's coming from outside the room. Generally, when you've got sound coming from outside the room, you want to stop that sound on the outside and not deal with it once it's entered your structure. So in terms of sealing of air gaps, this is a fairly standard product, and generally a big jumping off point for most timber structures is a good quality breathable membrane wrapped around the outside of your structure and sealed so that you don't have any flapping, any tearing, anything like that. Of course, the benefit of using a good quality breathable membrane is it will protect the building during construction, and it will reduce ruin noise. Something that's not always commonly understood, but if you look at a 3-layer CLT panel, which is not edge glued, this is not an airtight element. And because noise or sound travels through air gaps, you'd find that in these little gaps that were coming through in your CLT panel, you may find that if you had to be very, very critical of it, it will also be a passageway for sound. So simply adopting a membrane in this application will save you some acoustic, well, it will give you some added acoustic performance. The next step would be to seal off, further seal off gaps, especially around windows, doors, reveals. And Rothoblaas supplies a variety of different sealing tapes. I've given you basically in a hierarchy of what we have in stock in South Africa, the different types of tapes, the easy band, speedy band, flexi band, smart band, which is very, very good for stagnating or standing water, for example, on windowsills. And then we, of course, we have plasterable sealing bands for windows and that kind of thing onto masonry structures. So very, very handy products to seal off air gaps. And really, this is I think in my experience, I've certainly walked past many, many windows that are closed and the windows are still whistling at me as I walk past. Just something about, I've mentioned a split backing tape over here. This is an example of a split backing tape where you can create internal and external corners with the split backing tape. So very simple. You can, it's well, self-described and a very good way to seal off air gaps and add an element of waterproofing to your structure. Of course, we also have membranes for open facades where it may be exposed to UV rays, where your cladding is open effectively, and also different types of membranes for higher fire ratings, UV resistance. And these are monolithic, which is basically a chemical reaction as opposed to a microporous reaction. And just some basics on good practice for sealing membranes, or using membranes and tapes around windows. So just a step-by-step instruction on that. The next group of products, which I think should be in each timber framers or CLT guy's toolbox, is a range of expanding profiles and foams. We have a variety of them, expanding bands. These tapes or these profiles will expand, so generally it's a good idea to have a clamp on them. And we have them in a variety of different pedigree, as well as different types of fire resistant and more cost effective and high performance foams. The advantage of something like an expanding profile is you do not have to tool it afterwards, whereas often with foams, once you've used them, you do have to tool them. The converse side is usually once you've used an expanding profile, you would then generally seal it with a construction sealing tape afterwards. So it just depends on how one wants to work and what your desired outcome is. To come to my second point, adding density. I really like this construction detail. I think it makes a lot of sense. You have your exposed timber beams as almost like a permanent formwork, as well as your soffit. You have an acoustic mat. In this case, the green acoustic mat you see is called a silent floor beatum. You have your perimeter separation, which is right up at the top. And this is to prevent flanking or noise transmission from going around the element. And you have your starter bars, mesh, and CTC or concrete screws create a composite floor, and you can be using something like a screed or a lightweight screed to create a very good composite floor, engineered composite floor. Get the benefit of using possibly less timber than one might use if it was pure CLT. Also, another way to add density to a wall, for example, is a silent wall, which is also a bituminous-based membrane, which can either be stapled to a wall or silent wall beatum, which is self-adhesive. And these will also dampen sound traveling through, for example, a timber frame wall or possibly a light steel frame wall. So off-the-shelf solutions with known values of decibel reduction. Some acoustic and ceiling profiles. These I've basically listed them in hierarchy. Construction ceiling is a very typical ceiling gasket for regular joints. It's made out of EPDM, very cost effective. It can be widely used around sites to join panels, to block off air gaps, to create nice, well-sealed structures. The next product that we'll be looking at is a product called Track. This is an untested product. It's tested, but it's not certified. So it's a good performance product. We've seen some very, very good results using both Track and your Aladdin stripe over here. These can be split down the middle for smaller sections. and also a very, very effective way to block off sound. Going on to the slightly more technical side, we'll be looking at products like piano. And these piano and the next one that we'll see is xylophone. These are designed to work with loads on a timber structure. So your shore or your hardness and your softness will depend on the load applied to it and also on the acoustic load. So you'll see there's quite a wide range of the different products, which of course we can work with the designers on specifying the right one. Then of course, xylophone, these are for really big multi-story mass timber buildings, and their hardnesses will increase based on the load. So lower down on a building, you will have a much harder or a higher shore xylophone membrane or xylophone tape, and this will decrease as the building raises depending on the load of the CLT walls and floor panels. With that, you will also get a xylophone washer, which is designed to stop flanking noise from screws going from one side of a floor or a wall and basically reverberating it into or transferring that noise into another CLT or another part of the structure. Here you can see xylophone plates as well. Angle brackets are also, because they are steel elements, but also then insert or isolate the steel elements with a xylophone plate to prevent noise transmission from running through them. So you can see these are high performance products for large loads. Yeah, and that is essentially my talk. One thing I'd like to leave you with is I've got a Slovakian colleague, and he was mentioning to us a house that he knows of, a CLT house where it had kids' bedroom, family bedroom, or kids' bedroom, spare room, parents' bedroom. The kids could hear the parents, or sorry, the parents could hear the kids play with the spare room in the middle. So spare a thought for what the kids would hear. So I'll leave that.
Oh, that's a delightful thought. Thank you. Thank you, Mark. Just going to go with some questions in the Q&A, or I think there was one at least, from Miles Hollins. And I think this one is for you, Philip, are the SANS 10103 and 10218 mandatory standards?
I'm not sure about that. It probably depends on the project. A lot of times, new developments will probably specify that depending on the developers. So I'm not entirely sure. And of course, there's a lot of existing buildings that that perhaps also not conform to certain acoustical performances. So yeah, it's a good question, and I'm not entirely sure of the application in new builds, and probably depending on the developer.
Thanks, Philip. And then I think a question for Niel is, how did you design to keep monkeys out? Because I noticed in particular, it seemed quite open plan. So perhaps you can just answer that for Stefan.
Yes, that's a good question, and that shows that some of you people have been out in the bush. Monkeys are not born naughty. They're born as any other wild animals. They roam and they look after themselves. And during all our time on site, during construction, when we camped there, as I say, in the middle of nowhere, there was nothing there in the beginning. We saw a lot of them, but they kept their distance, and they still do. It's people that make them naughty when they leave stuff out or they feed them or whatever. And I'm sure that will happen in time, in which case they will become a problem. They're not down at the moment. So all we have done is we have designed the kitchen cupboards to be lockable. So and people are told to not leave things lying around, but if they do become a problem, at least you can lock things away in the cupboards. And I don't think the Mozambican monkeys have managed to turn the keys in the locks yet. Who knows?
Bram de Villiers, you have a question then?
Niel, I just want to ask you, maybe you can elaborate a bit on the different treatments that you gave the different timber elements in the building. What sort of treatments did you give against mold and termites, etc.?
Yes, Bram, good question. All the timber was CCA treated before the time in White River Sawmill's factory, even the laminated pieces, and they pre-treated the laminated pieces and only glued them afterwards to make sure that they are properly treated. Same goes for all the other SA pine members that were used in paneling and so on. The exposed timber we treated with Timber Life Satinwood 28, which is a product made in Centurion in South Africa. We've been using it for years all over the place, in the Namib and the Kalahari, everywhere. It's a treatment that penetrates. It's an oil-based treatment that penetrates the timber. It's got a wax compound which prevents moisture penetration into the wood. It's got other stuff in there that keeps hojas away. And then if you put a stain in your product as well, then it breaks down the UV. That is really bad for exposed timber in South Africa, especially up here on the Highveld. So we done that, 3 coats of that. And that was basically it. All they've got a different product that they use on decking, also made by Timber Life. It's called Ultra Deck. And all it does, it leaves more of the treatment on the actual surface of the timber, of the decks, which is good because that then is better at repelling water than when it all draws into the timber. And then the big secret about timber, obviously, is that you have to keep on treating them. You can't just do it once and then forget about it. We've specified, if I remember correctly, that the exposed timber, the structural timber mostly, and the decks, obviously, would have to be treated every 6 months for the first 2 years, and then afterwards every year, and then, just keep an eye on it. Certain parts will get more exposure to, especially the sun or rain maybe, where gutters fall onto timber, decks and so on. So those areas might need more treatment.
Thank you, Niel. Peter Leroux, I see your question in the Q&A box. If it hasn't been answered sufficiently, just let me know. But I think Niel has given a fairly comprehensive answer. I'm now going to allow the microphone for Francois. You can unmute and ask your question.
Thanks, Samantha. Francois Retief, I got a question for Mark. The application of the acoustic mat with screed, is that an internal or external application? What I'm asking is, if you had an external situation with a CLT flat roof or something like that, can that mat double up as a waterproofing membrane or not?
It wouldn't. Look, it is a waterproofing membrane in terms of protecting the timber from the whichever screed or concrete that you're putting down at the time. So that is a bituminous-based product. It's not what we'd consider a permanent waterproofer, so it wouldn't be something like torch-on. So if you wanted to add density to a CLT flat roof, for example, you could use that product, but I would certainly then do a waterproofing layer on top of that. Typical conventional waterproofing layer on top of that. One would also need to understand, if it's a flat roof, is it going to be trafficked on top? And will that trafficking it on top, will that affect people underneath it? So, but yeah, to answer your question, it's a temporary protection for that, but certainly not permanent waterproofing.
Okay, cool. Thanks.
Thanks, Mark. And then I think another question here for Niel from Anzet is, with the CCA treatment being discontinued in Europe for environmental reasons, will this also filter through to South Africa, and are there any alternative treatments?
Yes, I'm not sure about the exact answer. Maybe Dr. Philip Crafford is the man to ask. But I know that some of the other treatment methods have been discontinued over years because of that same reason, and I'm sure that it might get to us as well. At the moment, it's not the case. All the timber is treated with CCA. The alternative I know of is a boron treatment that also keeps the bugs away. But it's not done on wider basis. Maybe Bram knows more about it than I do. I know they do a lot of timber work, timber construction as well. But that is an alternative I know about that will prevent your wood from being eaten by bugs and also prevent dry rot, which is a big problem in timber construction, walls and, well, mostly walls.
Yeah, Niel, I think that's always a issue, the CCA treatment, but it's certainly with our termites and nasty things, it's a definitely must. You can use the boron treatments but not so. It's still used, but at the moment I don't see any kind of alternative treatments. You get Accoya, which is a acylate. It's basically putting acid to the wood, which is a Accoya treatment is a very sustainable treatment. It's non-toxic. I think Jamie Smiley used that Accoya treatment for that building in the Cape where they've got the external CLT panels. Accoya is just very, very expensive, but it is if you want to, if it's definitely where you have where you let's call it have to have a sort of eco-friendly treatment, Accoya is definitely the one to go for. I think Brad Anderson from Universal Ply, they've been developing a local product, and for the moment I can't remember that, but that's also a acid type, let's call it wood treatment option. Maybe Mark, you can just also elaborate on that.
I think I will also chip in. Yeah, CCA is still one of the probably best options for most applications because it has different classes that you can treat timber to for external use and outside use and internal use. So you will get a much better guarantee and the client would be a happier client. So at this stage, CCA is one of the best options still. There might be more, or there's alternatives available, and SOPA and guys like Timberlife will definitely have more of those options that they can share. But I must say, I'm still, I think CCA is still one of the best options if you to be sure of your project's lifespan in South Africa.
Mark, were you going to add to that?
Yeah, I was just actually, I understand some of these treatments, and see, Bram put me on the spot a bit, and I actually was quite curious to understand if these type of timbers can be used for structural applications, because I understand sometimes they can't. So maybe someone with a bit more knowledge than me can enlighten us.
Yeah, I think the one big discussion on, especially on CLT, is that it's difficult to treat CLT because obviously you first have to treat the timber and then you have to stick it together with the glue. And sometimes there's a lot of debate around if after the treatment of the timber with, say, CLT, now you have to laminate, and if the lamination is going to be that effective. But certainly people like Marcus van der Hoeven at MTT, they've done some of this CLT treated timber as panels. So they've also been working quite hard at treating CLT. So it's an option. Again, if you treat the CLT, it's obviously much more expensive. You first have to treat the timber and then you have to laminate it.
Thank you all. So I have put the email address for SOPA, the South African Wood Preservers Association. So if you do have any specific questions, perhaps also direct it to them. So I've put it in the chat as well as on one of the questions. I've got another question here from, I can't see their full name, but it's a question for Philip. So what factors influence the foundation size of timber frame buildings considering wind uplift? Hope I read that correctly.
Yeah, that's. I'm not sure if I understand the question entirely, but it probably, yeah. Usually, if you do a certain design, it's good to make sure, if it's especially the moment you go to a bigger building or a double-story building, to have the right structural engineer on board, because there's a SANS 10163 that will go hand in hand with the SANS 10182 or double 1082 for timber frame construction. And so designing structures or timber structures will then have to be incorporated according to the engineering specifications as well. And yeah, so you will have to include a structural engineer to confirm the foundation size, especially wind uplift. If you do yeah, some cool designs like Niel did, I think, and in coastal areas where you have high wind speeds, especially Cape Town area, those type of consideration is very important to make sure that you still have a roof after the winter.
Thank you, Samantha, thank you for the opportunity. Without wasting much time, let me thank the presenters today, Dr. Philip Crafford from the University of Stellenbosch, and also Niel Crafford from PlanEco, and Mark from Rothoblaas. Thank you for your excellent presentation and the excellent work that you are doing, and for sparing time today from your busy schedule to come and share your knowledge with us. Let me also appreciate our sponsors who made this webinar today possible, namely Rothoblaas, Sawmilling South Africa, University of Pretoria, through York Timber Chair, and the University of Stellenbosch, and the organizers, Bram de Villiers from Earthworld Architects, and Samantha. Thank you very much for the work that you did today. I was saying that the DTIC, in partnership with our various stakeholders, who are implementing 2 master plans as part of our reimagined industrial policy. These 2 pieces of plans aim to achieve fast-growing, profitable, inclusive, and sustainable furniture and commercial forestry sectors, while also encouraging sector growth, investment, job creation, and improving competitiveness in the industry. Let me also steal this opportunity, Chair, to also encourage students and professionals to enter into our furniture design competition for 2024 with the theme Shading Light on Great Design. These are some of the initiatives that, as the department and our partners, were trying to raise and nurture design capabilities in the country, and also raise the image of furniture design in our country and globally, and also introduce a new product. Within the furniture industry, also in partnership with the IDC, the department and the IDC offers concessionary loans and funding programs that offers funding to SMMEs in the furniture industry through what we call Furniture Challenge Fund. The department, also in partnership with other stakeholders, will stand for the promotion of timber in construction due to its benefit as presented today, such as sound absorption qualities, light, carbon footprint, and lower energy consumption compared to other building materials. The benefits are also going to be felt in our economy through support of demand in the upstream industries such as sawmilling, and also create new jobs through the development of our bioeconomy. This can also assist our country and government in its quest to build more houses. We know the benefit of how as quick a house can be constructed using timber. So without wasting much time, Chair, I would like to thank everybody who attended our webinar today and encourage all members to, in future, participate in the webinars that will be held, and also in the workshops as you presented them in the beginning of this webinar. And as the DTIC, we will continue to be present in all the workshops and webinars as arranged by the industry. I will wish you all a very good day today, and thank you very much.
Thank you so much, July. I really appreciate the DTIC's support of these initiatives and what government is doing to enhance our sector and make it more sustainable, resilient, and obviously profitable. So thank you to everybody who attended today. We really appreciate your attendance. We will send out the document that I shared a little bit later. And I see people have asked for detailed sections of the drawing, so we'll try and share some of the presentations as well. I wasn't able to, for some reason, insert the documents into the chat. So we'll follow up with an email with the supporting information, and then you should be able to access it accordingly. We will also submit the attendee list to the South African Institute of Architects, and hopefully if you attended the full webinar, then you will be eligible for those CPD points. So thank you, and have a wonderful afternoon. Thank you and goodbye.